Swayam Prabha. Digital India. Educated India.
Welcome to this course on transition metal organometallics in catalysis and biology. Today we will be talking about ring closing eneyne metathesis reaction, or in short it is called RCEYM. Now this discussion on ring closing eneyne mechanism has been a discussion that has been going on in the past few lectures, where we have tried to characterize this particular type of reaction. And what we have learned is that this ring closing eneyne metathesis reaction, they occur first in high dilution conditions, because these are intramolecular reactions, whereby under dilute conditions the competing intermolecular reactions like cross metathesis reactions for the alkene and alkyne substrates are suppressed. Also what we have learned in our earlier discussion is the fact that this eneyne mechanism metathesis reaction mechanism proceeds via ene first pathway, whereby the metathesis occurs on the alkene first, then subsequently moves on to the alkyne. The reason for this is that if the reverse were to take place, that if it were to proceed by alkyne first mechanism, then the regioselectivity is lost than what is observed in terms of the with regard to the product formation. So, today we are going to take a look at some more examples of ring closing eneyne metathesis reactions, or RCEYM. Ring closing in eneyne metathesis reaction. So, this is illustrated for the substrate shown given below. For the catalyst CH2. Now, the reaction would proceed by forming the corresponding metal of cyclobutene species, as is shown by here. This active species would react with the alkene first in the alkene first pathway, giving the metallocyclobutane intermediate, as it is shown over here, and then that would also undergo rearrangement, as is shown here, to give the active species like this. Now, that would then react with the alkyne in the fashion shown over here, to give this intermediate. Now, this can then undergo rearrangement as shown here to give and that in presence of another olefin would give the desired compound. So, this formation of this is favored. So, this is another example by which this pathway is favored. There are some possibilities or other possibilities like formation of a semi-membered ring as is shown here. Something like this is not observed. So, the favored product is what is shown over here. So, we are going to take a look at some more examples of this ring closing in ion mechanism. In wine metathesis reactions, and this we have worked out in some examples, and this in short can be represented by a substrate having an alkyne as well as an olefin, and this in presence of the catalyst which is a metal carbene species. The product is a diene of the type R1 and R2. So, this is a conjugated diene of this formula. So, in the past few lectures we have taken a look at several of these kind of reaction. We are going to take a look at few examples of this type of chemistry as is shown over here. Here is a biphenyl substrate that in presence of a tungsten carbene Fischer type of complex, the product which formed thus is So, this was reported by Professor Katz in 1985, and what this reaction shows is the fact that this moiety, this conjugated moiety is formed in the product as well and can be seen over here. So, the above is a general representation of this ring closing enine metathesis reaction. So, we are just going to take a look at a mechanism, cartoon mechanism proposed for these kind of substrates. Which is shown over here. This R, then R reacts with the metal catalyst, Now, there are two possibilities that this can undergo in first mechanism, or it can undergo in first mechanism, and there is also a possibility that possibility that there can be a metallocycle, there can be a metallocycle formation mechanism. So, there the proof for the or support for the in first mechanism was given by Katz in 1985, and the Trost proposed this metallocycle mechanism in 1991. However, the most popular mechanism to gain clearance is the in first mechanism, and that is the one which is now believed to be gaining grounds. So, let me just show the mechanism proposed by Katz, which is the in first mechanism, and the one that is shown by Professor Trost as well. So, in the in first mechanism as proposed by the Katz, it is supposed to attack the in first, giving the metallocyclobutane that further giving then it is attacking the olefin are now are, so this would result along with the product R. Now, in the crossed mechanism, what is said is, so this is the cat's ion first mechanism, which is this, and the crossed mechanism is this in present of acetate and the metal would give a metal cycle which would be which will undergo reductive elimination and release the metal to give this metallocyclobutane compound that would then undergo rearrangement to give the desired product. So, this is the crossed pathway apart from the in first mechanism which we had discussed earlier. So, even though the in first mechanism is by far the most popular one, there are possibilities of ion first as is shown over here, where alkene getting reacted with the metal catalyst, and other is the metallocycle as proposed by Trost. These two mechanisms have been proposed for this alkene alkyne metathesis reaction. However, they have not met with much success though. So, Cat's mechanism involves formation of metallocyclobutene intermediate in a in first pathway, whereas crossed mechanism involves formation of metallocyclopentane intermediate, and however they are different. However, the most popular, the inverse mechanism is by far the most accepted one. The inverse mechanism by far is the most accepted one for the Eneyne metathesis reactions. So, proceeding further, here is a nice example of vinyl cycloalkenes are formed vinyl cycloalkenes formation with high stereoselectivity. This is explained for the in the example CO2 ET, CO2 ET so this has a easy ratio 80:20 easy ratio in presence of ruthenium catalyst. It provides makes the 6-membered ring with this conjugated olefin in high yields 86% yield and greater than 98% E olefin. So, this is a highly selective way of synthesizing this vinyl cycloalkenes ring using this Eneyne metathesis reaction. So, the major drawback, despite the successful utility of these reactions that we have covered, the major drawback of this Eneyne reaction as discussed earlier is the formation of other metathesis products like the drawbacks homodimeric products. So, pros and cons of Eneyne metathesis. The limitation is cross metathesis reaction. Reactions. So, this is the limitation. Now, one thing to note here that the in accordance with Eneyne metathesis where there is an olefin and alkyne which undergoes metathesis, there are also reactions which are in metathesis. And the limitation for this in mechanism, the limitation is homodimeric products, is the formation of homodimeric products. Similarly, homodimerization is not a issue for in-ion metathesis. Similarly, homodimerization not a problem for in-ion metathesis. And one major important feature about metathesis reaction is they provide viable alternative to many other reactions like Wittig reactions or McMurray synthesis. Metathesis reactions provide alternatives to classical Wittig reaction and copper catalyzed alkyne coupling and McMurray synthesis. So, with this we come to the end of today's discussion on ring closing in-ion metathesis reaction. What we have observed in today's class is that we have looked at various mechanistic pathways which has been proposed for explaining in-ion metathesis reaction. To begin with, we had already in earlier class looked at in-first mechanism pathway in which the alkene undergoes metathesis first, and in today's lecture we have looked at two other proposed common pathway. One is the ine first pathway proposed by Katz, in which the metathesis of the alkyne is first proposed, though we had already discussed that this suffers from limitation because of loss of regioselectivity because of isomerization process that may happen, and beyond Katz's pathway, another proposed pathway had been by Trost, in which a 5-membered metallocyclopentane pentene has been proposed, but these two mechanism has not found ground in presence of the in first mechanism which we have discussed in detail. We have also looked into the variety of in-ion metathesis in terms of, we have looked to a new form called in metathesis, and what we had seen that cross metathesis is a problem for in-ion and homodimerization is a problem for in metathesis. However, for in-ion metathesis, homodimerization does not play much important role. Lastly, to summarize this metathesis reaction, what we had noted is that metathesis reaction provide a nice alternative to many classical reactions in organic chemistry like Wittig coupling or copper catalyzed alkyne coupling or McMurray synthesis. So, with this we come to an end of today's class. I once again thank you for being with me in this lecture, and I look forward to discussing this eneyne metathesis in bit more detail when we meet in the next class. Till then, goodbye and thank you.